We just learned the substitution method for solving a system of two equations. Now we're going to learn a second method called the elimination method, or perhaps the addition method. And before we get into details about it, let's use it using this hint on this system of two equations. Notice that the coefficients of the x's are opposites of each other. Well, that's very convenient for using the elimination method. The hint says simply start by adding the two equations together. When you add two equations together, you get another equation. Well, we're going to add these up column by column. And since the coefficients are opposite for the x's, when we add them together, we're going to get 0. So the x's will drop out. We've eliminated the x's. So add that column, we get a 0. Add negative 3y to 7y, and we get 4y equals, and then the right-hand side just adds up to, let's see, 43 minus 23 is 20. So that means by dividing both sides by 4, we get y equals 5. Very simple. We're only halfway done, and now we just repeat like we did with the substitution method. Go back to either of the two original equations, substitute y equals 5, and we'll find out what x is. I'll go to the first equation. Negative 2x minus 3 times y, which is 5, equals negative 23. So negative 2x minus 15 is equal to negative 23. Adding 15 to both sides, running out of room here, so I'll go back up here. Add 15 to both sides will give us negative 2x, and then negative 23 plus 15 is negative 8. Divide both sides by negative 2, and we get x equals positive 4. Now the solution, that means, is 4, 5. Okay, now you should go back and plug in x equals 4, y equals 5 to make sure it makes both of these equations work. If it only makes one of them or neither of them work, then you made some arithmetic mistake. Let's double check by looking in the second equation. 2 times x is 4. So 2 times 4 plus 7 times 5 would be 8 plus 35 equals 43. So that's correct. So that was a very simple example of using the elimination method. Why was it so simple? Because we started off with the coefficients of x's being opposites of each other. Similarly, we would have had an easy go of it if the coefficients of the y's were opposites of each other. So here are some rules we need to remember on using the elimination method. Equivalent linear systems. If you apply any one of these three row operations to a system of equations, you will result in an equivalent system of equations. In other words, it has the same solution. So you're allowed to interchange any two equations, which that should be obvious. If I reordered these two equations and called this one equation 1 and this one equation 2, we're going to get the same result. So interchanging any two equations does not change the solution. We're also allowed to multiply or divide an equation by any non-zero number. For example, if you had 2x plus 4y equals 6, you could multiply the entire equation by 1/2, which is the same as dividing by 2, and you get x plus 2y equals 3. This equation has exactly the same solution as this one does. If you were to graph this, you'd get a straight line. You graph this one, you get exactly the same straight line. Third one, you can add or subtract any multiple of one equation to or from any other equation. So if I wanted to, I could multiply equation 1 by 3 and subtract it from equation 2, something like that. Okay. We're going to use those rules and the elimination method to solve this system of equations. Now, there's a couple ways we could do it. What I think I'm going to do is eliminate, well, actually we're told here, eliminate x. Normally you won't be told that. You can either eliminate x or y. For example, if this coefficient negative 3y happened to be negative 7y, you would simply add the equations together and you would eliminate the y's in that case. So if we're going to eliminate the x's, we need to make these coefficients opposites of each other and then add together, add the two equations. How are we going to do that? Well, let's use some of these properties. We can multiply or divide an equation by any non-zero number. So how would I do this? I could think, well, let's think of the tougher way first. If I only wanted to change one of the equations, I would need to I'd have two choices. Either turn this 2x into a negative 5x, and what would I multiply by? Negative 2.5. A fraction, which works perfectly fine. You'll get the correct answer, but I'm going to try to stick to integers or whole numbers. But I could either multiply this equation by 2.5, or I could divide, or I could multiply 5x. In order to turn that into a 2, I could multiply it by 2 over 5. Now, I know that that's not what we want to do, probably because we're getting fractions involved. But the simplest way is just to multiply this equation by this number 5. And multiply this equation by this number 2. Only we need to make one of them negative, so maybe I'll do the negative 5. So when we do that, notice we're going to get a negative 10x for this term, and we're going to get a positive 10x for this term. But I have to multiply this negative 5 by every term in this equation. I have to multiply this 2 by every term in the equation. So what's our new equation number 1 going to be? Negative 10x, negative 5 times negative 3 is positive 15y, equals, and what is negative 5 times negative 19? It's a positive 95. And now let's do the second multiplication. 2 times 5x is 10x. That was our goal there. That's going to cancel out. 2 times 7y is 14y. 2 times 25, 50. Okay, so when we add these two equations, that cancels out. So we'll get 14 and 15y, that would be 29y, equals 95 and 50 would be 145. Dividing both sides by 29, I'll write it way up here. The 29's cancel, leaving us y, equals, and 29 times 5 is equal to 145. So 145 over 29 is 5. And now, just as usual, let's go back to either one of the two original equations. You could actually do this equation, or this equation, or this equation, or this equation, plugging the y equal 5 in and solve for x, and you'll get the correct answer. These are all valid equations. So let's just choose the first equation right here. 2x minus 3y, but y is 5, equals negative 19. 2x minus 3 times 5 is negative 19. So 2x minus 15 is equal to negative 19. All right, we're going to add 15 to both sides. I'm running out of room here, so I'm just going to make a note. We're adding 15 to both sides to get 2x equals, when we add 15 to negative 19, we get negative 4. Dividing both sides by 2 to get x by itself, x equals negative 2. Now I'm just going to do a quick check here to make sure that negative 2, 5, is the correct answer. Let's look at equation number 2. 5 times negative 2 is negative 10. 7 times 5 is 35. Negative 10 plus 35 is indeed 25, so we do have the correct answer.